let's do a few questions on evaluating the derivative of a function using the definition that we learned last class. Okay? So here's the example. Find f prime of x. Okay, so 1. F of x is equal to 1 over x. So f of x is 1 over x. F of x plus h is what? 1 over x plus h. And so f prime of x is equal to the limit as h approaches 0 of, so f of x plus h minus f of x over h. Okay, so you're going to hear this expression so many times that you're going to know it by heart. Okay. So equals limit h approaches 0, and now I'm going to replace f of x plus h by 1 over x plus h minus f of x, which is 1 over x, and all this divided by h. Okay, so now I have fractions on top of fractions, so let's find the common denominator on top. Limit as h approaches 0, so the bottom stays unchanged, and the top I will multiply by x here, multiply by x plus h here, and put everything on top over x times x plus h. Okay, so we have x minus, in brackets, x plus h. That's what I have on top. Okay, so basic algebra. Now h on the bottom is the same thing as h over 1. So I could write limit as h approaches 0, so it's a fraction divided by a fraction. So on top I have x minus h. Here I have x times x plus h, and instead of dividing by h over 1, I will multiply by 1 over h. All right, equals limit as h approaches 0, so the x's, they vanish, and I have negative h over, and on the bottom I have x plus h, and times h. Okay, so I could cross out the h's, and then I replace the h by 0, and what's left? I have negative 1 on top, and on the bottom, x times x plus 0, so just x2. So negative 1 over x2 is the right answer. Okay, so some of you got it, maybe four or five people got it. Okay, so some of you, I don't know, forgot, you gave me plus 1 over x2, so I'm guessing that you forgot to change the sign here. Okay, that's a typical mistake. You forgot to change the sign here. And so this minus didn't appear. This minus didn't appear because when you took out the bracket, you forgot to change that sign. Okay, that could happen. That's a few answers that I saw. Okay, let's do another one. Any questions on this? Okay.
No.
Good. Let's go. Let's continue. Number 2. So find f of x given that f of x, find f prime of x given that f of x is equal to the square root of x. Okay, so try this one now. F of x is equal to square root of x. f of x plus h is equal to the square root of x plus h. And so f prime of x is equal to the limit as h approaches 0, f of x plus h minus f of x over h equals limit h approaches 0, square root of x plus h minus square root of x. What do I do now? What do I do? I need to evaluate this limit, which is 0 over 0. What do I do?
Multiply by the conjugate.
Multiply by the conjugate.
Rationalize.
Excuse me?
Rationalize.
I can't hear you, I'm sorry. I think your microphone is okay. So on top, root x plus h, so it's x plus h plus root x plus h minus root x plus h, and then minus x. On the bottom, it doesn't change, root x plus h plus root x. Okay, so this big term and this big term disappears, x minus x disappears, and limit h approaches 0, so h over h times root x plus h plus root x. Cancel out the h's. Plug in h is 0, you get 1 over root x plus root x, which is 1 over 2 times root x. Are there any questions? Would you like another example, or could I advance?
Can we get another example?
Okay, let's do another example. Number 3. F of x is, let's say, 1 over the square root of x. Okay, so here's one a bit more complicated. F of x is 1 over the square root of x. F of x plus h is 1 over the square root of x plus h. And so f prime of x is limit as h approaches 0, f of x plus h minus f of x over h, which is limit as h approaches 0, and so the bottom is h and the top is, so 1 over root x plus h minus 1 over root x. Okay, so far so good? Okay, so again, fractions over fractions, I will do the common denominator on top, just like we did in the last example. Limit h approaches 0, so at the bottom, still just h. Top, so the common denominator will be root x plus h times root x, and here we'll have root x minus root x plus h. Okay. Again, this is a fraction, a big fraction over h over 1. So how do we divide a fraction by a fraction? I go like this. Root x minus root x plus h over root x plus h times root x, and then times 1 over h, so just over h. What do I do now? Multiply by the conjugate. Root x plus root x plus h, top and bottom. Okay, so equals limit h approaches to the top. I'm going to have again x plus root x times root x plus h minus root x times root x plus h minus, in brackets, x plus h. At the bottom, everything stays. Root x plus h times root x times h times root x plus root x plus h. Okay, that's out. So we have limit h approaches 0. On top I have x minus h, and on the bottom I have root x plus h, root x, h, root x plus root x plus h. Out. And I will have limit h approaches 0. So the h and the h will cancel. So I'll be just left with, well, okay, I'll just write it like this. Negative h over h root x plus h root x plus root x plus h. Actually, h go out. And then you plug in the h's 0 here and here. So I have negative 1 over, so root x times root x is x, times root x plus root x is 2 root x. That's what I have. Okay, this is good, or if you prefer, negative 1 over 2. So x power 1 times x to the half is x to the 3 over 2. You add the exponents. Okay, so there's not a lot of people who got this one. Maybe 4 or 5 maximum. Okay, so this was a tougher one. Are there any questions? Okay. Let's move on. Okay, anyways, I'm gonna post I think I did already, I posted a worksheet on using the definition to find the derivative. So you could do basically every question there, besides for when I ask you to find the derivative of a trig function, which I'm gonna show you later. Okay, maybe not today. Okay. Let's do a bit more theory. So remember, right? So just before I advance, just one quick reminder, what does this mean? What did we just find? Is that if I have the function here, f of x is 1 over root x, okay, which is a, I don't know, function, a certain curve, and I want to find the slope of the tangent to that curve at any value x, well, it's going to be equal to -1/2x to the 3/2. Okay, so right away, you could understand that the slope is always negative here, okay, because 2 is positive, x power 3/2 is always a positive number. So this is positive, so this whole thing is always negative. So from here, I understand that this function is always decreasing. Okay, just a little bit of insight. Okay, so I notice here that the derivative means the slope of the tangent is always negative, means that it's always decreasing the function. Okay, also, I notice that when x is equal to 0, the derivative doesn't exist, right? If I plug in 0 here, then there's no derivative. Okay, which makes sense because even in my function, if you plug in 0, the function is not even defined there. Okay, so anyways, we're going to go into details later in the course, but for now, just for you to be aware and for you to ask yourself some questions. Okay, so let's go with differentiation techniques. Okay. Okay. So what does differentiation mean? Okay, so differentiation equals finding the derivative. Okay, so differentiation techniques means I'm going to give you some techniques to find the derivatives without having to go through the pain of all these calculations that I just showed you. Okay, so there are a few properties that you need to know. Okay, so the first property, okay, the first thing is the linear properties of the derivative. Okay, what does this mean? Okay, what does a linear property mean? Okay, this, of course, everything that's linear, you're going to learn it very well in linear algebra. But just for now, introduce to you the concept of linearity. So, is that if you have, let's say, f of x is equal to, let's say, the sum of two functions, u of x plus v of x. Okay, so let's say f of x is the sum of two functions. Then if I want to find the derivative of f, well, I just need to do the derivative of u, the derivative of v, and add them. Okay, so I could just do u prime of v plus v prime, u prime of x, sorry, plus v prime of x. Okay, so this is the first property that the derivative allows me to do. Okay, same thing if this were negative. Okay, we'll do examples in 2 seconds. Okay, the second is that if f of x is equal to a constant k times a function, then the derivative will be the constant times the derivative of that function. Okay, so these are linear properties. Okay, so again, there's more to say here, but for calculus 1, I'm going to stop here and just make you apply this, okay, in a few minutes. Second property is what we call the power rule. Okay, so the power rule is that if f of x is equal to x to the power of any number, anything, okay, then the derivative, anybody know this one? Okay, well, you just bring the n in front times and you minus 1 from the exponent. Okay, these are the first two rules. And there are how many more? There's a product, quotient, and chain rule. There's 3 more rules after that. And then you're set. Once you understand all these rules, then you're going to go into a exercise sprint, examples for you to see a lot of these until it becomes second nature for you to find derivatives. Okay, so let me just do some examples on how to apply these 2 rules first, and then I'm going to prove the first one. Okay, I'm going to prove the linearity properties. Okay, and to prove the power rule, I could do it now, which is going to be much longer than if I wait for later in the course. Okay, so I'm going to wait for this one that we learned what we call implicit differentiation. Okay, which is later on, and then we'll prove this. It's going to be it's going to take us 1 line to prove instead of now it's going to take us 1 page. Okay, so let's do some examples. Let me move up. Let me just leave this in front of you. You can see it still. Okay, so let's do examples. So now I'm not going to go and use the definition, the limit definition. I'm going to use this property here. Okay, so example, find, let's change notation here, dy dx. If, so first of all, let's say y is equal to x2. Second, y is equal to x5. 3, y is equal to x. 4, y is equal to 7. Okay, then 5. Y is equal to, so x4 minus x9, then 6. Y is equal to 5 times x3, 7. Y is equal to the square root of x, 8. Y is equal to 1 over x. Okay, let's start with these ones. Just applying, oh, sorry, I can't see the bottom. Just applying the formulas, okay? Just applying the rules. Okay, so first one. So dy dx equals, what is this one? Can you tell me right away? According to this rule, so you put the 2 in front, and x to the power of 2 minus 1 is 1, so 2x. Okay, you get it? Which corresponds to what we did when we used the big definition. You remember, we did limit h approaches 0, f of x plus h minus f of x over h, and we found when we plugged in x2, we found 2x, if you remember. Okay, so now I think it's much simpler this way. It takes us right away, okay? And the second one, dy over dx will be what? Go ahead, shoot it, tell me.
4x.
What is it, 5?
5x.
5x4, right? 5x4, you have to do 5 minus 1 on the exponent. Yeah, you get this? Anybody doesn't get it? Okay. Number 3, dy dx will be what?
1.
1, perfect. Okay, because it's 1 times x power 0. And x power 0 is 1. Okay. 4, what is it?
0.
0, because this is like 7 times x power 0, and x power 0 is 1. You put the 0 in front, right? You put the 0 in front, you get times 0. So this is 0. So right here, I understand that the derivative of any constant is 0, which makes sense because it's a constant function, so it's flat, and so the slope is 0. We know that. This one here, dy dx is what? 4x3 minus 9x8.
9x.
Is that okay? Okay. Number 6, dy dx is what?
15x2.
15x2. And number 7, dy dx is, so this is like x to the power of 1/2, right? So it's 1/2 times x to the power of 1/2 minus 1 is minus 1/2. Okay, which is the example we did a few minutes ago. And we wrote 1/2 root x, okay? 1/2 times root x, which is, if you send this on the bottom, you get root x. And this one here, dy dx will be, so this is like x to the minus 1, so it will be minus x to the minus 2, which is negative 1/x2, which matches what we found before. Any questions? Before I continue.
Can you repeat the last one, please?
Sure. The last one here?
Yes.
Okay, so this is like x to the minus 1. Okay, so this is just like y equals x to the power of minus 1. Move up a bit. Okay, and so dy dx, so you put the minus 1 in front, times x to the minus 1 minus 1, that's minus 2. Is that okay?
Thank you. Yeah.
Okay, so try a few more, okay? Let me give you a few more. And I'm going to give you time to do it now. Now that you saw me do some examples. Okay, so that was number 8. So let's do now number 9. Let's say y is equal to 3 square root of x minus 2 over x cubed plus 1. Number 10, y is equal to 5 over the 5th root of x2 minus 3 power 7 plus 2x. Okay, just these two. The first thing I need to do is rewrite this in exponents form. So this is equal to, so 3 times x to the half minus 2 times x to the negative 3 plus 1. Now it's easier to see. Okay, because now I recognize the power rule and the linear properties. Okay, so dy dx is, so I put the half in front, 3 over 2x minus 1 from the exponent, so you get minus a half. Then minus 2 times minus 3 is plus 6. X to the negative 3 minus 1 is minus 4. plus, well, the derivative of a number is just 0. Okay, so that's my answer. Okay, so some of you were close, but you put in the +1, or there was always a mistake. You have to be very careful. Okay, so second one, number 10, same idea. So this is, I'm going to write in exponential form, so 5 times. So how do we turn this into exponential form? So it's 2 over 5. 2 over 5, and since it's on the denominator, so it's minus like this. Then minus 3 to the power of 7, and then plus 2x. Okay, so how do I do this now? dy dx is equal to, now I'm going to derive this. So I'm going to multiply 5 times negative 2 over 5. So this is going to be negative 2 times x to the negative 2 over 5 minus 1 is negative 7 over 5. And then the derivative of 3 power 7 will be, so you put 7 in front, 7 times 3 power 6, right?
No.
No. Okay, you understand this is not good? That's a trap. You see 3 power 7, you continue, you feel all excited, and you're good at putting the exponent in front.
0.
But this is not a x. Okay, so there's no x. This is a number, and a number, you derive a number on its own, it becomes 0. Okay, so this term vanishes. And then here, this is 2 times x to the 1, put the 1 in front, it is just 2. So this is my answer. Okay, any questions?
No.
Okay, good. Good, we're getting there slowly. Okay, so what is there to do now? So of course, I need to give you some practice on this, but what I would like to do is show you the linear properties. Okay, so let's prove. So proof that if f of x is equal to u of x plus v of x, then f prime of x is equal to u prime of x plus v prime of x. Okay, so that's a proof now. Okay, so I'm going to put a question mark here because I didn't prove it yet, but this is what I want to show. Okay, so every time we want to prove something, we go back to the definition. Okay, so again, f of x is equal to u of x plus v of x. Then f of x plus h is what? What is it? U of x plus h plus v of x plus h. Okay, and so therefore, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h, which is equal to the limit as h approaches 0. So f of x plus h is this guy. So it's u of x plus h plus v of x plus h minus f of x, which is this one, u of x plus v of x, and all of this over h. Okay, so I'm going to reorganize the top. Limit as h approaches 0. So u of x plus h minus u of x plus v of x plus h minus v of x, and all this over h. Okay, or if you prefer, I could just put each one over h. Doesn't matter. Same thing. It's like the whole thing over h. And so I could distribute the limits. Limit h approaches 0, u of x plus h minus u of x over h plus limit h approaches 0, v of x plus h minus v of x over h. Okay, do you recognize this? This is exactly u prime of x plus, and this is exactly v prime of x, definition of the derivative. And so I showed that f prime of x is u prime of x plus v prime of x. Done. Every time you finish a proof, a little black box here to show that the proof is over. Okay, any questions? So let's prove the last one for today. Okay. Can I change paper? Done?
Could you wait, please?
Yeah, go ahead.
I have a question.
Sure.
Can you just re-explain the step 2?
Sorry?
Can you re-explain the step 2?
Step 2?
Yeah.
What is step 2?
The third line.
This?
This one.
Nothing. I did nothing. I just did. I open everything on top. So I have ux plus h plus vx plus h minus ux minus vx, right? And then I combine ux plus h minus ux plus vx plus h minus vx. And I separate it into two fractions.
Okay.
Just basic algebra. Okay.
Yeah.
Okay, let's go next. Last one. Okay, so another proof. That if f of x is equal to a constant k times u of x, then f prime of x will be k times u prime of x. So same idea. F of x is k times u of x. F of x plus h will be k times u of x plus h. Okay, so f prime of x is limit as h approaches 0, f of x plus h minus f of x over h, which is the limit as h approaches 0. So f of x plus h is k times u x plus h minus f of x, which is k times u of x, all this over h, I could extract a k, I could factor out a k outside. K times limit h approaches 0, ux plus h minus u of x over h, and this we know, this is equal to u prime of x. So it's k times u prime of x. Done. Okay, that was fast. Okay, I just showed that f prime is k times u prime. F prime is k times u prime. Okay, are there any questions? Okay, that's it for today. Our next class is, I think, next week, right? We have class tomorrow. Okay, next week. So are you done writing?
No, just one more minute.
Okay. Let me know when you're done. Okay, good. Okay, so how's it going? Anybody have questions?
No,
No, you're all good?
I'm good.
It's all,
Yeah.
it's all clear?
Yep.
Anybody else? Okay, so if you have no questions, I will post the notes, class notes. I will post the video, and you guys are able to access the video, right, on YouTube?
Yeah.
Yeah, it
Yeah.
works. Okay. Aren't you supposed, I have a question here, aren't you supposed to bring down the negative exponent at the end of the example before the proofs? Oh, like, for example, it's the power -7/5, send it in the denominator. You don't have to, but it's good. You could send it on the bottom and put like express everything in positive exponents. You could do that, yeah. You don't have to for now, but you could. It's better, actually. Okay, another question. The power rule, is it the same as the Hospital's rule? No, it's not. Not at all. Okay, but L'Hopital's rule, we're going to deal with it once we're done with derivatives. Okay, so not yet, because you have to know how to derive to the L'Hopital's rule, and this is it's a way to evaluate, a short way to evaluate limits. Okay, shorter ways. That's it. Am I going too fast for anyone? You guys okay?
You're good.
No complaints. I don't see your faces, so I'm just guessing. No answer. No, nobody's complaining, so I'm guessing you're okay.
Wait, sir, I do have one thing. Earlier when you were going through the web work questions, I missed the end of one of them. It was number 6. Do you still have that paper?
I will post it right after class, so you can see it there.
Oh, okay. All right.
Okay,
Thank you.
We'll look at the notes and see it's going to be there, but I should have it. Let me see. Web work. Yeah, it's here. I have it here.
All right. Thank you.
Okay, guys, we're good?
All right, so have a good weekend. I hope by now you have finished the limit worksheet and maybe the continuity worksheet, and you could start working on the derivative worksheet. Okay? So you're at home, you have time, you're saving time on going to school back and forth, you're saving a lot of time, use it to do math exercises. It's gonna help you a lot. Okay? Have a good
Thank
weekend,
you,
guys.
sir. Bye.
Bye,
Thank
sir.
you.
Have a nice weekend.
Bye.
You
Bye.
have a good weekend.
Bye, sir.
Bye-bye.
Bye, sir.